All right, Algebra 2 students, we're back in our absolute value syllabus in Tier 3 doing Lesson 3. Let's check off our booklet. Lesson 3 is combining all absolute value transformations. So the cool little thing I got here in this note section is we are going to match the graph to the equation. So let's think about what I have. So the way I do this is I look at the equation and I try to sketch it. I'm going to go black underneath all of these. I'm going to put a little crossbar thing that acts as my coordinate grid. This is just a sketch. It doesn't have to be perfect. It's just going to give me an idea so that I can make a guess of the correct graph to the right here. So what I'll do is I'll use this chart down here that we introduced earlier and make sure that I do my horizontals first, then any shrinking or stretching, then any reflecting, and then any vertical translation to sketch my graph. So if I start with this first equation, I see that inside I have a horizontal shift to the right 2, so 1, 2. And then I know that I have a vertical stretch by a factor of 3, so that means I know it's going to be getting bigger, kind of going that way. But I know it's also reflected because of this negative, so I know it's going to look upside down, kind of like that. And then I know lastly that I have a vertical shift of up 6. So I know that my vertex is going to be something like that, and it's going to be kind of skinny because of that stretch. So that's the one I think that's going to look like. As I come over here and look for a graph that looks like that, it's definitely B. And then I'll go to my next equation and I'll say, okay, inside I have a horizontal shift to the left 1, and then I have a horizontal stretch because remember, if it's a fraction inside, it's opposite of what we think normally. So it's a stretch, so that means it's going to be pulling it apart and a little flatter, so more like this than like the parent function like that. And then I also know that I got a reflection, so it's going to be upside down and flat, so it's going to look something like that. And then I know that I got a vertical transformation down 1, so it's going to be down in this area somewhere. So I know I'm going to be something like that. When I come over here, I look for that kind of graph. Hey, and looky right there. Letter D. And we should all recognize this one right here as the parent function. We've been graphing it throughout these notes. So we know that this absolutely looks like that right there. And A is definitely the parent function. And then now going to our last one, we want to look in here and we see that we have a horizontal shift to the right 2. And we have a horizontal stretch by a factor of 5. So it's going to be a flatter looking thing like that. And then we also have a vertical stretch right here by a factor of 4. So it's going to be flat and pulled up, which is going to be a little goofy looking. And then we know that we are above the x-axis because of this vertical shift by a 2. So if you look real closely right here, you can see that that's a very small 2 right there, and that's where our vertex starts. I know that 4 is C.